In the previous video, we looked at differentiation, so now we're going to look at integration. So let's say you've got a function defined by this power series. This power series will then generate all these terms. And then now you can actually integrate each individual term. So when you integrate this, it will then become a0x. Integrate this, that will then become, well, you integrating this will then be you trying to search for something in such a way that when you differentiate it, it will then give you this. So make this to be your initial guess, x minus c minus, make this to be your initial guess, squared, and then stick your an here, stick your 1 here, sorry. And then now when you differentiate this, it will then become, well, the 2 will come down here, so that will be 2a1, and then the bubble stays intact, and then you times the derivative of the bubble itself. By the way, this should be a 1, and then you times the derivative of the bubble itself, which will be 1. So times 1, so that will remain the same. So if you're trying to integrate this, so you would make the initial guess to be this, but then if you differentiate this, it will then give you this thing here. You don't want this 2 here, so you would try to negate this 2. So you would go back to your initial guess and then make the adjustment. If you make this adjustment half here, then when you differentiate this, it will then give you this thing without the 2. So when you integrate this, it will actually be a1, and then this bubble here will be x minus c, and then it will be to the power of 2, and then you want this half here, so it will be this. So when you integrate this, it will then give you this thing here, okay? And then when you integrate this, it's really you trying now to integrate this, you're really looking for something in such a way that when you differentiate it, it will then give you this. Well, make this to be your initial guess, x minus c to the power 1 notch higher than this. It will be to the power 3, and then you've got your a2 here. Well, if you differentiate this, it will then give you, well, the 3 will come down here. That will be 3a2, and then the bubble stays intact, x minus c. This gets minus by 1, so that will be 2, and then times the derivative of the bubble itself, this bubble here, which will be 1. So when you differentiate this, it will then give you this, but you don't want this 3 here. So you would go back to your initial guess and make the adjustment a third. Well, if you integrate this, it will then become this a2 x minus c, and then 1 notch higher than this 3, and then you want to negate this 3 here, so you would want to divide it by 3. Well, anyway, integrating each individual term will then give you, bear with me. Integrating each individual term will then give you, well, if you integrate this, it will then give you this. Integrate this, it will then give you this. Integrate this, it will then give you this. Integrate this, it will then give you this, and so on. So now once you're here, you want to convert it back into your summation form. Well, here you can see that you've got x minus c to the power of 2. Here you've got x minus c to the power of 3. X minus c always stays the same, but then each power gets incremented by 1 each time. But because we want to convert this back into our summation form, let's change this to x minus c. It will be the same thing, because if you now differentiate this, it will then give you this term here. So let's just imagine this x here to be x minus c, just to keep it consistent with all these x minus c, x minus c, x minus c. So when you come to turn it back into your summation form, it will be, well, it's got to contain x minus c in your summation. And then you notice that this is to the power of 1, to the power of 2, to the power of 3. So but the thing is, it should be one notch. This thing here should, so this is 0, this is 1, this is 1, this is 2, this is 2, this is 3. So it's always like one power above your am. So when you integrate this, and then you've got your 2 divided by 2, divided by 3, divided by 4, and so on. So it will be n plus 1. Starting, this time you start at n equals 0, and then all the way to infinity. Well, converting this back into your summation form will then give you this. Okay, but then don't forget your constant, capital C. So this whole thing here plus a constant. So so notice that when you integrate this function here, you can actually integrate it. If you just look at this bit here, if you integrate this, the power gets increased by 1, so it will be x minus c, and then the power, well, you can just integrate it straight away. From this you can actually jump to this, because if you try and integrate this, it will be x minus c, the power, it will be one notch higher, and then your constants here, and then you would make your adjustment n plus 1. So, well, the point I'm trying to make is that you can integrate it straight away from here all the way all the way to here without having to go through each individual term. You can just do it straight away, because look, to the power of n plus 1, and then well, it's very similar to how you would integrate normally. It will still work with summation as well. So when you integrate this, it will then give you this. Okay.